Hello all, and a warm welcome to this live webinar on extending real-time service assurance with 360-degree visibility to Telco Cloud. In recent times, we are increasingly seeing network function virtualization, NFV, and software-defined networking, SDN, are being deployed by network service providers in commercial networks in the world. While network service providers are keen to adopt disruptive technologies such as NFV and SDN to facilitate rapid deployment of new services at improved ROI. They know they cannot afford to sacrifice service performance. The concern arises primarily due to the usage of commodity hardware, which are not designed for supporting real-time applications. Thus, there is a need for tools and mechanisms that measure network service performance in a collaborative fashion by accurately measuring and help correlating optimal performance of commodity hardware and related IT infrastructure needed to deploy the services. Service providers armed with such tools can confidently deploy their services on NFV-based environments. This webinar will highlight the key challenges faced by telcos and how Veryx gives solutions for them. In this webinar, we will be covering challenges faced by telcos while deploying NFV-based services, understanding potential bottlenecks in NFV infrastructure, how to diagnose the bottlenecks and overcome them. Finally, how Veryx provides the needed capabilities for monitoring and visibility for delivering services using NFV infrastructure. Let me now introduce our presenters. Our first presenter is Mr. Anton Basil.
Hello everyone. I'm glad to be speaking in this webinar.
Anton is the Vice President of Technology and R&D at Veryx Technologies. Anton drives the overall technology direction and engineering efforts related to Veryx SDN, cloud, and NFV offerings. He has over 2 decades of experience in the networking industry, spanning across broadband access, carrier Ethernet, routing, and security. Our second presenter is Mr. Selvaraj. Selvaraj heads product engineering efforts at Veryx and contributes to innovation across diverse technologies, many of which have won globally recognized awards. He has over 2 decades of experience in the networking industry, spanning multiple technologies, including broadband access, carrier Ethernet, and mobile backhaul. Hello, Selvaraj.
Hello, everyone. Hope to find this webinar helpful.
Thank you, Rennie. Let me talk about challenges faced by service providers. Before we talk about challenges, let's touch upon what is happening in service provider space. In recent times, we are increasingly seeing network function virtualization, NFV, and software-defined networking, SDN, being deployed by network service providers commercially around the world. While network service providers are migrating to disruptive technologies such as NFV and SDN to facilitate rapid deployment of new services at optimized cost, they know they cannot afford to lose service performance. This concern arises primarily due to the usage of commodity hardware, which are not known to provide the required performance for real-time applications. Now, let me talk about the challenges faced by telecom providers while deploying NFV-based services. The first challenge for service provider IT team is to identify suitable components to host their network functions. The identification of suitable server becomes difficult due to availability of wide range of servers from various vendors like HP, Dell, IBM, Cisco, and Intel. Each vendor having range of servers having different combination of predefined configurations. Hence, going through the vendor server offering and selecting the ideal server for the requirement is a cumbersome task. These servers having different processors with varying number of cores, number of threads, processor frequency, amount of L1, L2 cache, number of sockets, bus speed, amount of RAM, number of memory channels, memory bandwidth, type of storage disk, etc. Apart from hardware configuration, the operating system running on the server will make a lot of difference. The operating system could be Linux distributions like Ubuntu, CentOS, SUSE, Red Hat, and Windows. With or without accelerators like DPTK should also be considered as a challenge. Next comes the hypervisor, which is the key component of virtualization on a server. Hypervisor could be EXX and EXXi from VMware, Hyper-V from Microsoft, Zen Center from Citrix, Oracle VM, KVM, etc. With having so many permutations and combinations, it is daunting for service providers to benchmark all of them manually before choosing them. Next challenge is all the network functions are becoming virtual. In NFV environment, the network functions, which is part of the dedicated hardware like access switch, aggregation switch, routers, etc., will be virtualized as virtual network functions, VNFs, and hosted on a telco cloud. Now, the trouble is the inability of existing tools to monitor the performance after virtualization. The tools, in addition, has to perform virtual function performance, the performance of internal connection between virtual functions, and performance of the virtual functions along with the service chaining on a particular hardware. During these additional activities will be a tricky task to perform. For the network functions running on a virtualized environment, measuring the service performance as well as troubleshooting the performance degradation over time remains a major challenge. Next challenge is diagnosing and isolating of faults in the virtualized network. As NFV environment comprises of distinct entities, service network, server hosting the network functions in telco cloud, network within telco cloud, and network to access the telco cloud. Service providers should ensure that every entity should work properly to provide the best service. In case of failure, they are also equipped to isolate the problem, whether it is in the server which is hosting the virtual function, within the telco cloud network, connectivity to the telco cloud, service provider network. Next challenge is the service assurance for a service that is so dynamic, agile, and on demand. How do we assure service performance in an environment where virtual network functions are added and removed based on the dynamic need of the service? These services are activated and deactivated based on user requests and made available for user requested duration. Now, we need to assure the service performance such as dynamic, on-demand service offering, which is a challenge with currently available tools. Apart from being virtual and dynamic, VNFs are orchestrated across servers within or across data centers. As the network functions are orchestrated to provide optimal performance, measuring service performance using traditional methods don't work, and thus pose a challenge in assuring service performance in orchestrated environments. This requires that the monitoring components be flexible enough to be orchestrated based on the VNF migration so that service assurance can be ensured even when the VNFs are orchestrated. Final challenge is scalable services. With network virtualization, the resources are unlimited and the services can scale to any limit. Service assurance solution should also be scalable enough to measure these boundless scalable services. In NFV, service providers have flexibility to deploy additional VNFs when the resource demand for the service grows. This leads to a situation where the number of VNFs that will be onboarded will not be known upfront and the scaling of VNF will happen dynamically. Moreover, the scaling of VNF will happen either in the same server or another server in the same data center or even another data center itself. So, we are in need to have a solution which can scale up and along with the scaling of VNF in the NFV infrastructure. Having covered the general challenges faced by telecom service providers in deploying network functions infrastructure, we will now look at two use cases to deep dive and understand how these challenges can be overcome. In the first use case, we consider the scenario where the network functions VNF are hosted on a telco cloud. Let's now see how the challenge discussed here can be overcome. Here, we need to monitor the following entities: the service provider network, connectivity to telco cloud, server hosting the VNF, and network connecting the servers, basically the connectivity between the VNFs. To monitor these entities, we need to place probes at multiple locations to monitor the performance of service provider network, connectivity to the telco cloud network, and server hosting VNF. In this use case, let's assume that there is degradation in service performance, and now we are diagnosing to find out the reason for degradation. We need to look at following segments between customer premise equipment, link connecting telco cloud, between the network functions within telco cloud, and server hosting network functions. By inserting test probes adjacent to each critical component, we can identify the problematic segment contributing to service degradation. Now comes the next use case. In recent days, consumers are increasingly using value-added services from service providers like viewing movies, infotainment channels, and playing online games. This is our second use case for today. Here, we are covering a scenario of how service providers can monitor and ensure that their value-added service provide highest quality of experience to their consumers. This use case is different from previous use case where the application performance is being monitored instead of network function performance. Here, we need to deploy probes that can perform application performance monitoring specific to the value-added service offered. We need to deploy probes both at customer premise and cloud hosting the application. This way, we can constantly measure the application performance and alert if there is any degradation which will affect customer satisfaction. With the understanding of challenge and requirement, let's look at the solution offered by Veryx. Over to you, Selva.
Thanks, Anton, for giving a good overview of various service assurance challenges and how it can be overcome using two NFV use cases. Let me give a very brief overview about Veryx before getting into Veryx solutions. Veryx is an innovative provider of network test and measurement. Veryx SAMTEST solution covers monitoring and visibility of IP, MPLS, and carrier services. The Veryx Retina solution covers monitoring and visibility of cloud and data center network infrastructure and usage of SDN and NFV. Some of our recent industry recognitions include one from Gartner, Frost & Sullivan, and so on. For more information, you are welcome to visit our website. Now, let me talk about Veryx monitoring and diagnostic solution that will help you guarantee service assurance in totality. I'll be talking about Veryx SAMTEST and Retina solutions that will help you to assure service quality for the services offered through NFV architecture. Let's consider a use case. A service provider is offering a customer service and the network functions are hosted on the cloud. The service offered here could be a carrier Ethernet service or IP service offered to the end customer. We are going to see how we are monitoring, isolating faults, and tracing the path of failure in the service offered in this scenario using active performance monitoring. First and the foremost in this scenario is the placement of monitoring probes. Placement of probes are important and it will help in isolating different service segments. Following that, we'll need to understand the type of service, either carrier Ethernet or an IP service, to be monitored. This information is needed to generate the appropriate monitoring packets to proactively monitor the service. For a layer 2 service, standard service OEM packets, ITU standard Y.1731 packets are exchanged to monitor. And in the case of layer 3 service, the choice of ICMP or UDP echo or SWAMP packets are exchanged to monitor. In this case, we'll be placing the probes at customer premises and the server hosting the network function. Please note that the probes need to be hosted at either end of the forwarding graph to measure the performance attributes at the telco cloud. With this placement of probes, Veryx SAMTEST will be able to measure the performance attributes in the carrier network and the telco cloud. With this performance information, we'll be able to isolate and pinpoint the location of bottlenecks in the service offering and fix it quickly. Veryx SAMTEST monitoring can be configured to monitor either 24/7 continuous or periodic. SAMTEST also triggers alerts via email or SMS when SLA thresholds are reached. SAMTS also maintains a complete history of the monitored performance attributes, which can be used for carrier network or the cloud network behavior analysis. Let's see another use case of over-the-top of service offered by service providers as value-added services. The difference of this use case with respect to the earlier use case is that the use case uses application traffic for monitoring performance, whereas the earlier use case used standard layer 2, layer 3 frames for monitoring performance. Again, the same measurement principles of earlier use case holds good here as well. The placement of probes and the application time. Based on this measuring principle, the probes are placed at the customer premise and on the telco cloud where the applications are hosted. With this placement of probes, we will be able to measure the performance attributes in the carrier network and the telco cloud. With this performance information, we will be able to pinpoint the location of bottlenecks in the service offering and fix it quickly. Now we are going to talk about Veryx Retina solution, which focuses on data center infrastructure monitoring. Retina is a unified proactive infrastructure monitoring and diagnostic solution for data center, cloud, and enterprise that presents the live status of all infrastructure entities and provides comprehensive diagnostic information for troubleshooting. Retina collects metrics related to server, storage, network devices, and the network connectivity between them. It provides key performance indicator metrics and threshold crossing alerts on a unified dashboard. It also correlates the metrics and provides valuable inferences based on the correlation. Retina has the ability to detect all the resources, server, storage, network devices, etc., and provide topology information dynamically in near real time. Also, Veryx virtual probes can be spun up dynamically, which will help to determine the network bottlenecks and network connectivity issues. With support of Veryx virtual taps, Retina provides visibility to the traffic between virtual machines and thus ensures the IT administrators are able to better understand the nature of such traffic, whether it be for compliance or for security. Veryx Flow Analyzer is network-based application performance manager with real user experience monitoring. It provides comprehensive end-user experience monitoring and broad visibility into your application bottlenecks. Veryx Flow Analyzer passively monitors the network and collects packet, application, and transaction data for fast troubleshooting. Using high-speed packet acquisition and multi-stage analytic processing, it delivers powerful capabilities such as automatic application discovery and rich application insights, end-user experience monitoring for web and non-web applications, and response times. Moreover, it delivers real-time and historical application transaction analytics, voice over IP, and video on demand quality monitoring, and deep network intelligence. Veryx Flow Analyzer is an integral part of the Retina solution for end-to-end performance management. With a holistic view of data center performance plus the ability to contextually drill down into domain-specific details, helps to reduce the number of handoffs between IT domain groups and provide resolution time for application and network iterations. Now that We have a fair understanding of Veryx samples and retina solution and its capabilities. It is very easy to infer that these two solutions will be able to provide 360-degree service assurance to services offered by service providers. Samters taking care of service assurance of the carrier services or IP services, and Retina taking care of data center service assurance and visibility into traffic flow.
Hello, now we are very glad to answer any of the questions from audience. The first question for today. Being all the components are monitored actively, how do you ensure that the packets used for monitoring does not affect the bandwidth allocated for the service?
Yes, thank you for your question. We considered this and made the polling interval as configurable. Based on the significance of the components to be monitored, you can configure it from minimum to maximum interval. Our solution allows to configure the intervals at 100 milliseconds or 1 second or 10 seconds. More the interval, the less the bandwidth consumption.
How do you ensure that vProbe does not impact the VNF or network service performance during performance testing?
That's a good question. Veryx probe has been designed such a way that it doesn't interfere with the cores and resources allocated to other VNFs running on the server. So this way, the impact on the VNFs will be literally nil.
Can I manage your probes with my management system?
Veryx solutions provide RESTful service on the northbound interface. So your management system can manage your controller through the RESTful service, which in turn will help you to manage our probes.
When the vProbe is also part of the service chain, what is the impact on the network service when the vProbe encounters a failure?
We need to understand that vProbe is not in line with the traffic that flows through the VNF forwarding graph. vProbe is only getting linked to the forwarding graph to generate the required traffic for measuring the service performance. Hence, even in case of vProbe failure, the ongoing network service will not get impacted.
What is the rate of traffic your probes can analyze?
That's an interesting question. Our probes are built on the top of DPDK library, so which in turn helps us to analyze traffic up to 10 gigabytes.
I think that brings us to the end of this webinar session. Any questions that have been missed now will be answered over email. We would like to thank you all, audience, for taking time to join us for this webinar today, and we hope the information we presented was useful. If you find our solution interesting and would like to see a demo, or if you think our solution could address any of testing challenges you are facing, please feel free to reach out to us. The email IDs of the speakers are listed in the slide you see. You may also reach out to us by writing to info@veryxtech.com. Our website is www.veryxtech.com. Please feel free to browse through our website for more information of Veryx solutions. Once again, thank you all for joining us today.